Okay, part 11 of 25 on Euclidean Geometry. We are going to see the theorem that says angle at the center is twice the angle at the circumference. Okay, so the angle at the center of a circle is twice the angle at the circumference of a circle. Okay, so let's see that. Let's say you have a circle and you have this angle O1 and this angle O2. Okay, you have two angles at the center, O1 and O2, and you have another angle B. Okay, let's call it B. You have another angle at the circumference. So let's call this point A, and this point B, and this point C. Okay, so if you check, you are going to see that the angle O1 is subtended by this arc, and the angle B is also subtended by this arc. Okay, the angle B is subtended by this arc, the arc AC. Okay, let me show you. The angle B is subtended by the arc AC. You can see, if you follow the lines, you can see that. Okay, you can see the angle B is subtended by the arc AC, and you can see the angle at the center O1 is also subtended by the same arc. Okay, you can see, if you follow the lines, you can see. Okay, this angle O1 and the angle B are subtended by the same arc AC. So when you have the angle at the center and the angle at the circumference subtended by the same arc, now you can combine the two angles using this theorem. Okay, so we are going to see that. You have to see that the angle at the center of a circle is always larger than the angle at the circumference of a circle. Okay, the angle at the center is wide open. You can combine the two angles using this theorem if they are all subtended by the same arc. Okay, so now this angle O1 is equal to 2 times this angle. Okay, so the angle at the center, okay, O1 is equal to twice the angle at the circumference. Okay, twice the angle at the circumference. This can hold only when the angle at the center and the angle at the circumference are subtended by the same arc. Okay, you can see I have used arrows to show that the angle at the center and the angle at the circumference are subtended by the same arc. So this can hold. Okay, so for the above theorem, okay, the above theorem to hold, check that the angle at the center, okay, the angle at the center and the angle at the circumference are subtended by the same arc. Okay, in this case, you have the arc AC. Okay, so in the above diagram, the two angles, okay, the angle at the center and the angle at the circumference are subtended by the same arc AC. Okay, in this example, you have the arc AC. Okay, so arrows are used to show that the two angles, okay, the angle at the center and the angle at the circumference are subtended by the same arc AC. in this example, okay, AC, you can see the angle O2, okay, O2 is subtended by this arc AC, but the major arc, okay, this arc, let me show you. The major one, okay, this is a major arc AC, which is different from this. This is a minor arc AC. So for you to use this theorem, you must have the same arc subtending the angle at the center, okay, at the center, and the angle at the circumference, okay. So you can see. Now, another case, you can have a circle, okay, you have angle O1 and angle O2 at the center, and you have another angle at the circumference. Let's call it D. So let's call this point C, and this point D, and this point E. You have the angle D at the circumference, okay, which angle at the center you can combine with the angle D, okay. You have to see that the angle D is subtended by this arc, the arc CE, okay, this arc, this one, okay, CE, okay, this angle is subtended by this arc, and the angle O1 is subtended by this arc, okay, a different arc. So O1 is subtended by this arc, a different arc, but you can see O2 is subtended by the same arc as D, okay, you can see, okay, O1 in this direction, O2 in this direction. So you can combine this angle and this angle, okay. You have to check using arrows if you want. Now you have the angle O2 is equal to 2 times the angle D, okay, because they are subtended by the same arc, okay. So for the above theorem to hold, check that the angle at the center, okay, and the angle at the circumference, okay, are subtended by the same arc. In the above diagram, the two angles, okay, the angle at the center and the angle at the circumference are subtended by the same arc. In this example, CE, okay, CE, you can see. So arrows are used to show that the two angles, okay, angle at the center and angle at the circumference are subtended by the same arc, okay, CE in this example. Let me erase this. I want you to see this. This is what you have to notice about this situation and this situation. You are going to have always two situations, okay, when dealing with this theorem, the theorem that says angle at the center of a circle is twice the angle at the circumference of a circle. So for this situation, this is what you have to notice. You have to see that when the angle at the center is between 0 and 180 degrees, okay, greater than 0 but less than 180 degrees, you can see O1 is between 0 and 180 degrees, okay, like this. You can see O1 is between 0 and 180 degrees. So when the value of the angle at the center is between 0 and 180 degrees, you are going to have the theorem is going to hold for the angles in the same segment. So the angle O1 and the angle B are in the same segment. So if you draw a chord from A to C, okay, from A to C, okay, like this, you are going to have two segments, okay. This is a segment, this is another segment. Now you can see the angle O1 and the angle B are in the same segment. Okay, so in which segment? In the yellow segment. So this can happen only when the angle at the center is between 0 and 180 degrees. Okay, now for this situation, this is what you have to notice. Okay, when the angle at the center is a reflex angle, okay, the angle at the center, okay, O2 is between 180 degrees and 360 degrees, okay, less than 360 degrees, greater than 180 degrees. You can see O2 is between 180 and 360. So this is a reflex angle, an angle which is between 180 degrees and 360 degrees is known as a reflex angle. So the theorem holds for the angles in different segments. So the angle O2 and the angle D are in different segments. Okay, so if you join the arc CE using a chord like this, this is a different segment, this is a different segment. Okay, now you can see the angle O2 is in the yellow segment, the angle D is in the blue segment. Okay, let's solve these three problems. Okay, 1, 2, and 3. Okay, so let's start with problem number 1. Okay, determine the angle O1 and the angle O2. Okay, you have O1 and O2 at the center, and you have the angle ACB at the circumference. Okay, what you have to notice is that the angle at the circumference is subtended by the arc AB, and the angle O1 is also subtended by the arc AB. So you can combine the two angles using this theorem. Okay, you have to notice that the angle at the center is always larger than the angle at the circumference. Okay, the angle at the center is wide open as compared to the angle at the circumference. Okay, you can see the two angles are subtended by the same arc, which is the arc AB, and okay, you can see using arrows you can follow the lines. You are going to see that. So this angle is subtended by the arc AB, this angle, the 35 degrees. Even the angle O1 is also subtended by the same arc if you follow the lines. Okay, so you can see the angle O1 is subtended by the arc AB, even the angle at the circumference, okay, the 35 degrees, is also subtended by the same arc, the arc AB. Okay, so the question is to determine O1. You have an angle at the circumference which is subtended by the same arc AB with the angle O1. So this theorem can hold. So O1 is equal to, you are going to multiply by 2 because this is twice the angle at the circumference. So 35 times 2, you have 70 degrees. You have to write the reason. The reason is the angle at the center is twice the angle at the circumference. Now find O2. This is around a point. So around a point, you have O1 plus O2 is equal to 360 degrees. The reason is angles around a point. Okay, the sum of angles around a point is equal to 360 degrees. Now find O2. O2 is equal to 360 degrees. You take O1 to the right. O1 is equal to 70 degrees. So you are going to have minus 70 degrees. This is equal to 290 degrees. Now, example number 2. Determine the angle JKM. Okay, JKM. This angle. Okay, so when you follow the lines, you are going to see that this angle is subtended by this arc, by the arc JM. Okay, JM. Can you see? The angle JKM is subtended by the arc JM. You can follow your lines. You are going to see that. You can see when you follow the lines, you can see this angle is subtended by this arc. So the question is to find this angle. So you have the angle 110, which is an angle at the center. Is this angle subtended by the same arc? Okay, if it is subtended by the same arc, now you can use this theorem. So let's check. You can see the angle 110 is subtended by this arc. In this case, the angle O2 is subtended by this arc because you have the angle O2 on this side. The angle O1 is subtended by this arc because you have the angle O1 on this side. So 110 is on this side. It is subtended by this arc. So you can combine the two angles because they are subtended by the same arc. You can follow the lines. You are going to see that the angle 110 is also subtended by the same arc. You can see if you follow the lines. So in this case, if you draw a chord from A to B, you are going to see that the angle O1 and the angle 35 degrees are in the same segment. You have this segment and this segment. Now, in this case, after you discover that the angle at the circumference and the angle at the center are subtended by the same arc, now you can combine using this theorem. So, the angle JKM, okay, JKM is equal to, you are going to divide the angle at the center by 2. You are going to have 55 degrees, we have the angle JKM. Now the angle JLM, this angle, you can see the angle JLM is also subtended by the same arc. If you follow the lines, you can see. Can you see? Let me use a different color. Can you see? If you follow the lines, you can see the angle JLM. Okay, this angle is subtended by the same arc. So for this, the reason is, you have to write the reason always. The angle at the center is twice the angle at the circumference. Now the value of the angle JLM is also equal to 55 degrees, because you have the angle JLM is also subtended by the same arc. You can see, if you use an arrow, you can see, if you use an arrow, the angle JLM, okay, JLM is also subtended by the same arc. Okay, you can see. So the reason will be the angle at the center is twice the angle at the circumference. Now, if you draw a chord, you are going to have the angle at the center in the same segment with this angle, or with this angle. You have this segment and this segment, two segments. Okay, two segments. So after finding this angle, you can find this angle. So you can use this method to find JLM after finding JKM. So this is equal to JKM, because angles are in the same segment, subtended by the same arc, and angles are at the circumference. Okay, so JLM is equal to JKM. So this is equal to 55 degrees. And the reason for this, you are going to say angles in the same segment, or you can say angles at the circumference, okay, subtended by the same arc, JM. Okay, we are going to see this in 14 of 25. So now example number 3, determine the angle PRQ, this angle. So you have to see that this angle, the angle PRQ is subtended by this arc. Okay, this arc. Can you see the arc PQ? Now find another angle at the center which is subtended by the same arc. Okay, so this angle 100 degrees is subtended by that arc, a different arc, but this angle 260 degrees is subtended by the same arc. So you are going to combine this angle and this angle because they are subtended by the same arc. Always check that you have the angle at the center and the angle at the circumference are subtended by the same arc. You can use arrows to see that. Okay, so you have PRQ, this angle is equal to, you are going to divide by 2 this angle, not this angle. This angle is subtended by another arc. You have to use this angle. let me use the same color so that you can see. Okay, so you have this angle and this angle are subtended by the same arc. So you are going to find this angle using this angle. So divide by 2, you have 130 degrees. The reason is the angle at the center is twice the angle at the circumference. So you have 130 degrees at the circumference and 260 degrees at the center. So in this case, if you can draw a chord, you are going to see that you have two segments. Okay, this segment and this segment, two segments. If you can draw a chord, so the theorem can hold when you have angles in the same segment or angles in different segments. For different segments, the angle at the center is a reflex angle. Okay, so we are done.